Hello people, this is AJ sir. Let's study 10th standard ICSE Math chapter 14 exercise D, finding the slope and the y-intercept from the equation of a line. Math exercise 14B. A few fun facts to remember. X-axis has a fixed equation which is y is equal to 0, whereas y-axis has a fixed equation called x is equal to 0. Any equation of a line which is parallel to the x-axis will always be in the format y is equal to something. So remember, parallel to x-axis, y is equal to something. Y is equal to -3, y is equal to 3, whatever. Similarly, if a line is parallel to the y-axis, its equation will be x is equal to some number. Now in this exercise, we'll study how to find the slope and the y-intercept of a given line. If I have an equation in this format, y is equal to mx plus c, then we know that m is the slope and c is the y-intercept. Y-intercept means where the line cuts the y-axis. Cancel SE24. Now in exercise 14D, cancel 1.2 and 1.3. 1.1 is for homework. Let's do question number 2. The equation of a line is this. Find its slope and y-intercept, and also find its inclination. So first of all, we shall rearrange the term so that it is written in the format y is equal to mx plus c. Notice that here there was no coefficient for x, so we can assume it to be 1. That's the slope. And here c is -4. Don't forget to write the minus sign in the value of c. This is the y-intercept. Next, they have asked us to find the inclination. Well, if we know the slope, we can find the inclination of the slope because we know that tan theta is a formula for slope. And if tan theta is 1, then theta has to be 45. You should know the standard values of tan. That is tan 0, tan 30, tan 45, tan 60 and tan 90. Next question, 3.1. Is the line this perpendicular to the line that? So we'll find the slope of both the lines. If the product of both the slopes is -1, then that would prove that the two lines are perpendicular, because remember, when lines are perpendicular, their slopes are negative reciprocals of each other, and when lines are parallel, their slopes are equal. That's the property we are going to use now. So the first equation, I shifted 3x on the right hand side. I want y alone. Even here, I wanted y alone, but I didn't shift x on the RHS because that would have given me -y. Then shifting the negative sign may lead to some silly error. So I suggest whenever you have a -y, shift it. So that becomes y. And then just flip it. So it becomes y is equal to x minus 4. But here, I'm going to shift x and 7. 4 also will shift down. So we get -3 upon 4 as the slope, and -7 upon 4 is the y-intercept. Although there is no use of the y-intercept in this sum, slope is useful. So m1 is -3 upon 4. Next equation, same way. This time I'm going to shift -21y on the RHS. Because there is a negative sign, it becomes positive. Shift 21 down and cut. I'm getting 4 upon 3 as a slope. And of course here the y-intercept is 50 upon 21. But that's not relevant in this sum. What is important is the slope. We got the two slopes. Now check their product. And it does come out to be -1. This proves that they are perpendicular. If it was not -1, then they would not have been perpendicular. Now Roman number 4. Determine x so that the slope of the line through these 2 points is 2. So they have given slope is 2. But we know the formula of slope, y2 minus y1 upon x2 minus x1. 2 points are given, so you can assume any of them as x1, y1, x2, y2. Substitute the values, that is equal to 2, cross multiply. Only one unknown variable exists, x, so get the value of x, which is interestingly 0 in this case. 4.2, again an equation is given. Find the slope of the line which is parallel to this. So first we'll find the slope of this equation, and that will be the same slope for the line parallel to this, because parallel lines always have the same slope. So first of all, convert it into the standard format of the equation. Step number 1, LCM, get rid of the denominators, multiply by 6, everything. Step number 2, I want y alone, so I shifted to y and then shifted 2 down here. Okay, and don't forget to divide 2 entirely. This is the slope. So the slope of the other line will also be same, because parallel lines have the same slope. Next, 5.1. Find the slope of the line which is perpendicular to this. So first let's find the slope of that line, and we know that the slope of the line perpendicular to this will be a negative reciprocal of this. First of all, LCM, shift y, I want y alone, so I'm getting 2 as a slope. Remember, the coefficient of x is always called the slope. Y is equal to mx plus c. This is the y-intercept. So I'm getting the slope as 2. So the other slope will be negative reciprocal of the first slope, which comes out to be minus 1 upon 2. Reason has to be mentioned, perpendicular lines. Next, let's do question 6.2. Lines this and that are perpendicular to each other. What does it mean? It means that their slopes will be negative reciprocals of each other. Find the relationship between m and n, not the values but the relationship. That is some equation in which m and n only exist. Equation number 1, converted into the standard format, I'm getting y is equal to this x plus this. So this is the slope. That is m1, first slope. Similarly, second equation is given. Rearrange the terms and convert it into the format y is equal to mx plus c. Yeah, no need to write plus here, it's okay. Anyway, the intercept is not of any use in this sum. This is the slope 5 upon n. That's the second slope. Since the lines are perpendicular, we know that the product of the two slopes will be equal to minus 1. Substitute the values, cross multiply, and we get the relationship like this. 5m is equal to 3n. Next, question 7 is cancelled. Let's read question 8. The equation of a line AB is this. Find the slope of AB. Oh, that's easy. We know how to find the slope. And they've also asked for the angle it will make with the positive direction of the x-axis. That is, they want the theta, the inclination. That's easy as well. We'll use tan theta formula. So rearrange the terms, get y alone, and 2 upon 2 cut. So 1 is the slope, and if 1 is the slope, then the angle of inclination is 45 degrees. Now the ninth sum, the lines represented by this and that are parallel. That means their slopes will be equal. Find the value of p. Very straightforward sum. This whole exercise is very easy. Rearrange the terms so that you get y is equal to mx plus c. Surprisingly, there is already an m out here. Oh, well, it should be x actually. So y is equal to mx plus c. C is irrelevant here. Slope m is minus 4 upon 3. Don't forget the minus sign. Similarly, the second equation, again rearrange the terms. I'm getting y is equal to mx plus c. C is half, by the way. Slope is p upon 6. So I got m1, I got m2, and they're saying that they are parallel. That means m1 is equal to m2. Reason, parallel lines, which is, you have to mention the reason always. And cross multiply and get the value of p, and the sum is over. Next, 11th sum is cancelled. Question 12, let's solve that. Find the equation of the line passing through this point and parallel to the y-axis. I've told you there is a direct method. Whenever a line passes through the x-axis, the equation, not passes through, rather parallel to the x-axis, the equation will always be in the format. Which one? Try to recall. Y is equal to some number. And if the line is parallel to the y-axis, its equation will be in the format x is equal to some number. Okay, but which number? Well, this will be y is equal to, what's the value of y here? 7. So that's the answer. The equation of this line parallel to y-axis will be x is equal to some number which is a x coordinate here, -5. So answer is x is equal to -5. That's it. That's all that you have to solve. 2 steps and the sum is over. Next, let's do 13.1. Find the equation of the line passing through this point and parallel to this. First, I will find the slope of this. That will be the slope of the required line as well. So I have the slope and I have a point. If you have a slope and a point, can you frame the equation of a line? Yes, you can, using the slope point form. Remember, there were 3 types of sums in the previous exercise: slope intercept form, slope point form, and 2-point form, which is same as the slope point form. So we will use that formula to solve this sum. So we start off with the given equation. -3y goes to the RHS, it becomes 3y. 4 goes to the LHS, it becomes -4. 3 goes down in the denominator, so it becomes x upon 3 and -4 upon 3. So I get this standard equation. So 1 upon 3 is the slope. Since the lines are parallel, so the slope remains the same for the new equation as well. And this new equation is passing through a point 5, -3. So I'm going to assume that as x1, y1, because now when I frame an equation of the new line, I need x1, y1, and I want the slope. Substitute the values of x1 and y1 respectively. Be careful about the signs here. So this becomes y plus 3 and this 3 goes up. So when you open the brackets, you get this, rearrange the terms, you get x minus 3y is equal to 14 is the required equation. You could have even written this as x minus 3y minus 14 is equal to 0. That's the same thing, doesn't make a difference. Next, the 14th sum is cancelled. Let's do the 17th sum. 2 vertices of a rhombus are given and we have to find the equations of the diagonals. So let's draw the diagram first. Drawing diagrams are compulsory, without which you won't be able to understand how to solve. As soon as they mention the word rhombus, I knew one property which will come into play in this sum. Diagonals are perpendicular bisectors of each other. So they are perpendicular to each other and they are bisectors. That means O is the midpoint of the diagonals. So I can find the coordinates of O using the midpoint formula because I have these 2 points. That will come in handy later on. First, let's find the equation of dB. If you have 2 points, how do you find the equation? That's type 3, right? 2-point formula. First, we find the slope and that it becomes type 2. That is, we have a point and a slope. So we can frame the equation of line dB. So let's start with that. x1, y1, x2, y2. It could have been interchanged as well. Doesn't make a difference. BD. Always give the heading of what you are finding. First, find the slope. I'm calling it M1. I'm getting it as -1 upon 3. And now this is the format in which I will frame the equation. I got M. I got x1, y1. Be careful about the signs. Open the brackets. Rearrange the terms. This is the standard equation for line BD. That's the heading I had given. If you would not have given, then you would have to write is the required equation for diagonal BD. But I've given the heading, so that's fine. Now, how do I find the equation of AC? I need at least 2 things. I need 2 points, or I want a point and an intercept, or a point and a slope. I got nothing. So I'll have to find 2 things first. Since they are perpendicular, I can find the slope at least, because I know the slope of AC will be a negative reciprocal of the slope of BD. I need one more thing. Well, I can find the coordinates of O. So I can use the point slope formula to frame the equation of the other diagonal as well. Step number 1, write the reason why, what property you are using for solving the rest of the sum. Find the coordinates of O using midpoint formula. Now heading AC, slope, negative reciprocal of the previous slope, 3. x1, y1 also, that is O, taken. Now we start with the point slope formula, substitute the values of m, x1, y1, rearrange the terms, and this is the required equation of the other diagonal. Next, the 20th sum. It has two parts. Roman number 1. Write down the equation of the line AB, which is passing through point 3, 2, and it is perpendicular to the other line. So I got 1 point and I got the slope indirectly, because perpendicular means the slopes will be negative reciprocals of each other. So first of all, using the given equation, find the slope. For AB, find the slope. Perpendicular lines means that the two slopes are negative reciprocals of each other. I have 1 point at least given. So using the point slope formula, substitute and get the equation. Roman number 2. It says this line AB meets the x-axis at A and y-axis at B. Write the coordinates of A and B and calculate the area of the triangle. O is the origin. So let's draw the diagram first. You try it. Now I'm showing it. Check if yours is right. This is the diagram. This equation of the line AB is actually 2x plus 3y is equal to 12. First of all, point B lies on the y-axis, so its x-coordinate will be 0. And point A lies on the x-axis, so its y-coordinate should be 0. You should know that much at least. Let's find the value of y here and x here, because they've asked us to find the coordinates of A and B. One method is, we know that this point B not only lies on the y-axis but also on the given equation. That means it will satisfy this equation. So point B, 0, y, satisfies the equation, this one. So if I substitute x as 0 and y, I keep it as y, I solve and get the value of y. So I'm getting b is equal to 0, 4. Another method could be, do you know this y is nothing but the y-intercept? And you know, we can get the y-intercept directly. If only I can rearrange it in the format, which is 3y is equal to minus 2x plus 12. 3 goes down, so y is equal to minus 2 upon 3, which is the slope, x plus 12 upon 3, which is plus 4. So I have now written it in the format y is equal to mx plus c. And do you know what is c? The y-intercept. So I could have got my value of y directly like that as well. What about the value of x out here? Well, this also lies on the line, so it satisfies this equation. So same method here for point A. Please give the headings for point B, for point A. A satisfies the equation. Don't miss any step which I am writing. Even if you get the right answer but your steps are missing, you will lose marks. Follow the method I'm teaching. Substitute x as x itself and y as 0, solve and get the value of x, and hence you got the coordinates of A as well. Next, in order to find the area of the triangle, I need the base and I need the height. Height is nothing but the y-intercept, which is 4, and base is nothing but the x-intercept, which we calculated as 6. So area of a triangle is half into base into height, which comes out to be 12 square units. Next, question 22. Point P is the foot of a perpendicular from A to the line this. So it's best to draw a diagram to understand this. P is the foot perpendicular from point A to the line this. They've asked us to find the equation of line AP. I got 1 point and I can get the slope as well because it is perpendicular to this one. So first find the slope of this one. How do we do that? Well, y is equal to mx plus c, find the slope. For AP, the slope will be the negative reciprocal of this, which is minus 3 upon 2, they are perpendicular lines. Point, we already know 1 point on AP, which is point A. Use the point slope form and substitute the values and get the equation. Second point, find the coordinates of P. Well, P lies on this line as well as on this line. That means P is the intersection of two lines. And how do we find the point of intersection of two lines? By using simultaneous equations. These are the two equations. One of them was given in the question and the other one we found out, remember? Here. Solve them simultaneously. I'm equalizing the y coordinates, y cancelled. I get the value of x. I substitute it in equation number 1 back again to get the value of y. And that's how I get the coordinates of P. Hi students. If you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.